I'm Hilary Petticord and I work for the NOAA Science on a Sphere team, and I want to show you a really cool application you can use for distance learning as well as increasing data literacy in your classroom. It's called SOS Explorer, so you can download it from the mobile app store. It's free, and follow along. All right, we're going to do a mini lesson on human impact and global warming, but there are many things you can do, so I'll show you some resources at the end of the video. Okay, so this is SOS Explorer, and when you first open it up, you can see actually real-time nighttime, the day-night terminator, so nighttime lights and daytime. So it's morning here in Colorado, and you can see real-time clouds. So these are the clouds and weather that's happening across my country today. And I like to start lessons about climate change using nighttime lights. Carbon tracker is coming up soon. So what's one word that comes to mind when you see your planet in this way? Some of the words that come to my mind are light, night, civilization, globalization, electricity, cities, coal. It's true that the majority of the energy used to power our planet in this way is produced by burning coal. And that does have some consequences to our planet. Now, the next data set we're going to look at is air traffic. So we want to see a little bit more dynamic view of human impact. And this data set is not real time. There probably wouldn't be very many flights moving around right now during coronavirus pandemic, but there is this is a normal day, I think one day in 2007, and you can see the day-night terminator on this one moving around and the local time across the equator. So you can see different patterns between day and nighttime air traffic travel. But this, what we're going to do during this data set is just a simple math problem, kind of a simplified math problem. How much carbon dioxide goes into the atmosphere on one flight coast to coast in the United States? So that's my question. And our numbers are here. So 1 air mile produces 53.3 pounds of carbon dioxide. New York to Los Angeles is 2,450 miles. And so our equation is 53.3 pounds of carbon dioxide times 2,450 miles gives us how much for that one flight? So the answer is 130,585 pounds of carbon dioxide, or 65 standard tons of CO2 from one flight, which is pretty shocking, right? When you break those carbon-hydrogen bonds and add an oxygen bond, you get a very heavy molecule. And we get a lot of it. So this is 3 times 10 to the 10th gigatons, 30 gigatons, sorry, is what we are adding to our atmosphere every year. So that's 30 metric tons of CO2 is about what we add every year globally. And it's not that hard to imagine when we do that math problem, right? So the next data set I wanted to show you is called Carbon Tracker. So let's look at what is this actually doing to our atmosphere and what is it doing over time. So what we're looking at is a model that's produced in our laboratory in Boulder. So It's actually in the laboratory next door. So the Global Monitoring Laboratory is part of the Earth System Research Laboratories, where we work in Boulder. And you can see that blue, or the purple, kind of the cool colored side, is less carbon dioxide, and the warmer colors are more. And exact numbers are here on the color bar. And what I wanted to show you is this really cool thing you can do, which is draw, essentially, you can look at different probing points of data, but you can also draw a transect all the way down a longitude line to get a graph of carbon dioxide. So what's cool about this is that as we go on, I'm going to speed this up by selecting the playback speed. As we go on, we can see that carbon dioxide goes up in the northern hemisphere certain times of the year, and it goes down certain times of the year. And I want you to figure out this pattern for yourself. So what time of year does it increase? What time of year does it decrease in the northern hemisphere? And if you're in the southern hemisphere, do the opposite experiment. And then what happens over time? So I'm just really speeding this up, and I'm just going to go all the way to the end to 2015. So this is 15 years of data of modeling carbon dioxide patterns in the atmosphere. And we can see that it went up about 40 parts per million, which is what it used to go up over thousands of years prior to the Industrial Revolution. So what we see is carbon dioxide is pooling in the atmosphere. Although there's a carbon cycle, what we see is that it is not cycling back through, and rather it's pooling in the atmosphere. So what does this do for how it feels on the surface of the planet? We're going to choose temperature anomaly. And this one is correct on your mobile app. I have the wrong title here. So it's temperature anomaly annually between 1880 and 2017. And so temperature anomaly means that we're comparing what the average temperature of this particular year in this particular region compared to the entire 20th century average. So if it's red, it's warmer than normal. If it's blue, it's colder than normal. If it's white, it's the same or similar. So we're looking pretty early on here still. But if we fast forward using our animation controller to the year 2000, we'll start there and press play. We start to see a pretty obvious pattern, which is year to year, weather changes, temperature is different. However, the globe is predominantly red, which means the global average temperature is actually warmer, quite a lot warmer than normal, almost everywhere. And this pocket near Greenland is colder because of the melting ice. So there's one other way I wanted to show you to look at this, one data set left before we talk about our resources that you have access to, and that's called warming stripes. So we received this from a UK laboratory, and I believe this project was called the Climate Lab book. And if you ever want to learn about these data sets, you just push the I button here in the upper left-hand corner, and that will take you to our website description. So this particular data set is showing the same information, except it goes back a little bit earlier, but in a different way. Each line is the global average temperature. And we see a very distinct pattern. We do see, no matter when we're looking, these anomalies. So it's a little bit warmer, it's a little bit colder that particular year, but it's pretty obvious that over time, global average temperature has risen. Now I leave it up to you to talk about different ways that this is affecting life and ocean on our planet. But now I want to show you some resources here. So on our website, which is sos.noaa.gov, we have some phenomena-based learning modules. And we have broken these out into some pretty cool topics, as well as what we think are appropriate for certain age levels. And so these are jumping off points that you can use SOS datasets to engage your learners, to talk about different things like a tortoise that crossed all the way across the ocean. How in the world would a tortoise, not a turtle, make it all the way across the Indian Ocean? And then I also wanted to show you that on our SOS Explorer tab, you will find SOSX Mobile. And then if you click on resources, you can find this page, uses and resources. So why use data visualization in education? What skills are practiced? What topics are covered? How to use this in the classroom. So you can flip your classroom, you can do a presentation like I'm doing, or you can do direct hands-on learning. And here are some student examples that they can go and do on their own. So that is what I wanted to show you, and we really appreciate your feedback, and let us know how you use it. Thank you, and follow us on Facebook to see the latest and greatest.